So today's lecture will be on implementing user interfaces in Python. And we're going to talk about the Qt library and the binding that is used in Python to implement user interfaces. So if we start with user interfaces on many platforms, it's a kind of common day appearance today. When we have user interfaces, we need to implement them on Mac, on a Windows, on a Linux machine. And doing this in a platform neutral way is a bit hard. If you look at the platforms we have today, we have Linux, we have Windows, we have Mac OS, and all of them have their own ways of implementing the user interfaces. On Linux, we have X11, and perhaps now also in the future, we have something called Wayland. They are related, they can use the same APIs. On Windows, we have Win32 or WinRT, which is the newer API. On a Mac, we have UIKit and NSKit, which are libraries for similar libraries as for Win32 and X11 for implementing user interface on a Mac. So you can see here, if you want to do a single application on each platforms, you have to write one application that accesses X11 on a Linux machine, another application that accesses Win32, and another version that accesses NSKit. Of course, you can have in your applications, you can have parts that are similar on each platform, but the interface to the user interface libraries needs to be different on each platform. So there must be a better way of doing this, and there is. So what you can do is that you can add a layer on top of these user interface libraries. And that layer, in this course, we are going to use something called Qt. It's from a Norwegian company, and it's a C++ toolkit from the beginning. And it abstracts the different user interface libraries into a single library. So you only have to write a single application in a single source code, and that can compile on all the platforms. But as we have Python, we can't use C++ directly, so we have to put something on top of the Qt library, and that is called a Python binding. And a Python binding, that is a connection between the Python programming language and a C++ library. And that translates the call from Python to C++, because Python is not a compiled language, it's a dynamic language. And you need to kind of make a connection between and that is called the binding. And PyQt is one of the more common ones. There is also Python for Qt, and there's PySide, which all are bindings to Qt. So in this way, you can write a single application, and you can target all the major platforms. And it will behave as a Linux application, behave as a Windows, it behave as a Mac OS application. So they look the same on all platforms. So Qt is a platform-independent user interface library, as said before. And what it does is abstracts the user interface concept in a single library. So there is no need to call a native function if you're compiling on Linux. You can call a Qt function, and that will handle the connection to your to the native library for the operating system. Another thing that Qt is very good at is that it adapts the user interfaces to each platform. So you don't have to think about being a Linux application or a Windows application or Mac application. It will look like the native application on each platform. You can also in Qt style your user interfaces as well to look whatever you want them to look like. So you can basically have a style sheet that tells the library, this is how I want my application to look like. Qt also uses something that is a bit different from other user interface libraries, and is that events, that is mouse, keyboard, touch, is handled using something called signals and slots. I will go into that later here, but the basic idea on a high level is that a button has a signal that it sends out, and you can connect that to different parts of your code or your other controls. and you define something called a slot, and you connect the signals to a slot. So it's like connecting cables in your user interface. So as I said before, Qt is a C++ library, so you can't directly communicate with that because it's a binary object shared library that you need to kind of interface with. So you need a binding, and there are several bindings existing today. In this course, we are going to use the PyQt bindings, and especially the one called PyQt5. So we are not going to use the latest and greatest PyQt6, but something in between. There is also Qt for Python and Python Qt. So at some point they couldn't agree on what the official binding for Qt should be. I think that Qt for Python is the one that is maintained by the developers of Qt as well. Before we go into more programming details, I need to kind of cover a specific programming model here that we will use in developing user interfaces. Up until now, you have been coding, your program went from A to B, accomplishing some kind of task sequentially after each other. But user interface applications, in principle, they are just waiting for you to do something. And this do something is called an event. So when you click a mouse button, there's an event initiated, and basically your application is always executing a loop, waiting for messages to come into your program, events come into your program. And then you act upon those events and you do something. So if you click a button, you connect that to code that what happens when that button is clicked. So the event loop waits for messages and sends them out to your code. And the loop only exits when the last window has been closed. So it kind of checks, okay, is there still windows on the screen? Yes, then I continue looping. Has the user exited program? Yes, okay, then we can exit the loop as well. So it's a single endless loop until you close the last window. On a really high level event level, code can look like this. So you have a flag, running is true. And while we are running, first we check for, do we have any events? Yes, if you have an event, it returns event, and then you do check an event type. For example, okay, I have a button click. Then I have to handle the button click in some way, and I dispatch that to some other code. And then you have a large case statement or if statement here checking for the different event types. And of course, finally, then you have event type equals to application quit. Then you set the flag to running equals to false, and the program terminates. So this is on a high level here. And the signals of slots here will be, so the event loop, you will actually not see that in your PyQt code. It will be hidden. You start the event loop calling a function. That function will never exit until the final window has exited as well. Yeah, so one problem, as I said before, there are many bindings for Python, and which one should you choose? And the problem is that if you choose single one, your code will be non-portable between the Qt versions. So there is actually a way of solving this, and that is using the Qt Py module. So usually when you import, for example, PyQt, you use PyQt5, and you use that in the import statement. But using the Qt Py model, that model will check which Python binding you have available, and magically kind of transform your calls to these to the correct Python binding. So a simple program in Qt PyQt can look something like this. You have to import the widgets here. So widgets here is the main toolkit that contains all the controls. And then the first thing you need to create an application object. And you will see here that a lot of the object-oriented parts comes back here into Qt program. So you create an application object, and that is kind of the main mechanism to kind of control the complete application. You only have one application object, so that is a single object that you create. you give it the system argv here. So a Qt application has several command line arguments you can call it with. And what you do here is that you pass along the incoming arguments to the application here. And the application object will parse those and modify the behavior as necessary. So up until now, we don't have any windows on the screen. We just have an application over here. And that in itself is not something visible on the screen. So the first thing you have to do is create a window of some kind. And the most basic window you can create is a Q widget derived window. And you create an object here, and then you call the show method on this widget. That will bring the widget up on the screen. And then this will show the window, but now to be able to interact with the window, we have to start application loop. And that is done using the app.exec command. So this is actually the event loop itself. And that will never exit until all windows has been closed. And the sysexit here is just, we could have called only this part here, but the thing is that if there are some error codes, you can transfer them out from your script as well, and that will be returned on the outside as well. So this is just kind of the best practice way of handling starting the event loop in Qt. So we can see here. I will go to my node here, and then you do. So this is the same code here in my Visual Studio Code. I have some parts here that I've added here. These are, if you have a high resolution screen like you have on a Mac, it will tell Qt to kind of enable a higher resolution output of your application as well. So let's see if I can run this. And you can see here that I get the window. I can resize the window. I can maximize it. So all this behavior is built into the widget object. But basically, we can't do much more than this. But this is the event loop is running here, waiting for that. If you resize the window, it will adapt. And then when you can see here that we are still hanging here on the output here. If we close the window here, the program exits. So final window here will exit the application. And this is the loop that will kind of continue running all the time. And you can also see here that we have added QtPy here. This is the original version with the real Qt binding, and this is the QtPy binding here, so that we don't rely on which Python binding we're using. So as a QWidget is a base class for all user interface objects in Qt, and if you create a QWidget by itself, and there is now already a window, it will create Qt will create a window for that widget. So that was what was happening in our last example. We created a widget. It was the root widget. It didn't have any other windows associated with it, and then it added a window around it. You can also derive custom windows from QWidget as well. So you can specialize them to be either controls or other widgets. As I said before, Qt is very object oriented, and you can see here this is the hierarchy of you have a QWidget that is on top. You create your own window, for example, that inherits the QWidget base class, and then you specialize your own window here. And then you have your own window can have multiple objects connected to it. In this case, perhaps I have a line edit, which enters text, a label, a group. And the group is a special widget that can handle other groups. For example, you can move them together in a single layout. and so on. So you can have multiple hierarchies of groups in your user interface. So it uses all the kind of benefits of object orientation. What you should do when you implement your own user interface is that you specialize, you create your own window class that kind of defines your own behavior. And what you do then is you inherit from. You inherit from the widget class here, and then you add your own constructor, and of course you have to call the constructor of the inherited object or class. In this case, you have a super in it, and then I usually create my own method for initialize the GUI here. And here I can, for example, I can set the geometry of the window. This is this one here. And then I set the window title, what the name of the window should be, and then I show it here. So I don't have to explicitly call show when I create this object. So this will look something like this. So I have here my own class here defined. And then I create, instead of creating a widget here, I create my own window. And because I have show here, I don't have to explicitly show the window because that's automatically done when I create the window. So running this will look something like this. Now it looks kind of the same as the example before, but we have customized it here. So we position the window at 300 by 300, and then we set it should be 600 by 600 wide. So it's a square window. And also you can see it changed my window title here. Of course, we would like to have some more functionality of our windows as well. So next we should add some user interface controls that you can click on the window. And what you do then is that you add code to your init GUI again, and then you create, for example, a push button. And the push button is the simplest form of button. It's just something you can click and that will send some kind of signal and your code can respond to it. And it's similar to how you create objects that we went through in our last course here. So you have first, this is the class. I recall that, and you give it the caption of the button, what it should say. And the second parameter is the owner. So you tell this button is associated with this window here. So it will be attached to my window. Like I set a tooltip, and that is a small balloon that comes up. If you hover over the window or the control, it will show a help text. You can resize it, so you can set a different size of it, and you can move it to a certain location. Let's go to EX3. So I have my button here. And you can see here, now I have a button here, and you can see you get a lot of functionality without doing anything. And if you hover over, it will show this tooltip here. So I'm a button, please press me. And so this is the way you create controls and add them to your window. But now we have a control on our window, but we don't have there is no connection to any code. And that is kind of the point of creating a user interface, to be able to execute code for the user. And that is done using events and signals, as I talked to you about before. So every control, or most of the controls in Qt have several signals that they can send for different events. And for example, a button has a signal called clicked. And that is what happens when you click the button. So the mouse goes down and goes up again. That is considered a click. There's also an event called pressed, and that is if the button is held down on a button. So if you continue holding the mouse button down, the pressed event will be called. And then if you, for example, if you have a list box, there could be other signals, for example, current row change, that is, and a signal that is sent when the user selects a different row in the list box. And the connection is done using a method called connect. So for example, I have a my button object here. There is a clicked property here, and that has a method called connect. So you select the signal you want to kind of respond to, and then you do connect, and then you attach or specify which code should be executed when that button is clicked. And if you want to have more information about what events are available, you can go to the documentation pages of Qt. And every class there has a special section where all the signals are and what they do. And if you look at here, go back to our code again. Here is our self button click connect. And then you can see here, in my class for my window, I added a method here called on button clicked. And I usually name them with every event method. I usually put an on underscore prefix to kind of indicate to other coders that this is an event method that is being called in response to an event. You should kind of name them like on, and then what object is, button in this case, and then what is going to happen clicked. And you can see here, it should print hello when I click the button. So let's see what happens if we run here. And you can see here on the bottom here on the screen, it prints hello. So this is kind of a really easy way of connecting events to your own code. And then also there are some other things that most of the controls have. So for example, most of the controls that have a text displayed on them this text can be changed using the set text method, and it can be retrieved using the .text method. So .text will return a string, and set text will set the string on that control. You can also hide the visibility of your controls. For example, you can make it disappear from the window. You can use set visible here, and then you can query if it's visible or not using is visible. In certain cases, you want to hide from to the user if a control can be used or not in a certain situation. It could be that some state variables are not set, so you can't do certain calculation in certain parts of the code, but you still want to show for the user that there is an option here, but it's currently not enabled. And you can set the control to be enabled using the set enable method, and you can query if a control is enabled using the is enabled method. The focus, set focus here is a special method connected to so most of the user interfaces today in Windows and Mac have default actions for keyboard controls. So you can actually navigate in your user interface using keyboard controls. And for example, if you want to have enter text in some control, that control needs to have focus. And if you want to kind of steer the user to certain control that you should start entering text here, you can call the set focus on that control, that makes sure that the focus is in that control. And it's very important when it comes to text boxes, for example, that you can set the cursor in a certain text box, because that is the thing you want the user should enter first. So let's see here if I can show some example here. So control 1. So here I have 3 buttons here. I create them. I give them names 1 and 2 and 3. I connect the first button here to on button 1 clicked, the second button to on button 2 clicked. And then when you click the first button, it will check if the second button is visible. If it's visible, it sets visible to false, otherwise it sets it to true here. And then button 2 will check if button 3 is enabled. And if it's enabled, it will set it enabled to false, otherwise true. So here we can experiment with both the visible and the enabled, what happens when you do those. So if we run this here, you can see here I have 3 buttons here. If I press the first one, the second one will disappear. So this is the visible property. And if I click again, it will be displayed again. If I press this one here, it will disable the third button. And you can see here, the button is still there, but it doesn't react to my mouse anymore. If I press it again, you can see here it reacts to my mouse again, and that means that it's enabled. So by using the set enabled, you can kind of control what the user can actually select, but at the same time you can visually convey information about this will be available if some other state is true. So it's a way of signalizing that it's not enabled yet, but it's there if you do some other step, for example. I went through that already. Yes, you can also control how the windows should appear. That is done in the constructor of your main window. So the second parameter of your constructor controls the window type. And by default, you get a window that is resizable. It has a close button, a minimize button. But you can also tell it to be, for example, a dialog box. A dialog box, especially in Windows, has a special appearance. They are non-resizable, and usually they have like a question mark. And there's another window type that is called a tool window that has a smaller title bar, typically used for providing a toolbar to your application that can float around and present some important actions in your code. So window style. So let's start with, you can see here, this is the normal window. You have already seen it already. It has single bar, you have a minimize button, you have a maximize button, resize, and close. We do the dialog here. You can see here that I have a cross button, but I don't have a maximize. Actually, it's resizable as well. But this one, if you configure it, will bring up the help on this dialog box, for example. There's also a special window class in Qt that implements a dialog box functionality. So this is kind of just setting the appearance of your window to be a dialog box, so not actually becoming a dialog box. That there's a special Qt dialog box that you can use. And then finally, the tool window here. You can see here that the title bar is a bit smaller. There's only a small box here to be able to close it. So this is a toolbox window that you can use to have a floating toolbar window. You can also control the size of the window here using the window state. So if you want your application to be displayed on the entire screen, you can do set window state Qt window maximized. And we'll see what that does. Start with the window maximized first. Now you can see here, it started the window maximized on my entire screen. And there is one mode that is called full screen. And that can be used if you want your application to take over the entire screen, like a kiosk when you want to buy tickets in your for the train, for example. You want to create an application that covers the entire screen. Then you can set the window to Qt window full screen. You have to be a bit careful here, but because that window will not have any controls for closing it. So you need to remember that you need to use, for example, Alt F4 to close the window. So if I run this here, you can see here there are no controls here on any side of the window. So I need to do Alt F4 to close it. But it's good to know that it's there. So if you want to limit the user's ability to do things, you can use the full screen window. Next, normal applications on Windows and Mac, they usually have both menus and toolbars. The menus are a bit differently implemented on Linux, Windows, and Mac. So on Linux and Windows, the menus are displayed in the window. On Mac, all menus are displayed on top of the screen. So there are some different behavior, and Qt will handle it for you. And the object structure or class structure of menus are like this. So you have a top level class called menu bar, and that implements either the top menu bar on a Mac or the top menu bar in the window on Windows. And then you add menus to them. So the menus are the ones that are going from left to right, and then you attach submenus that falls down on each of these menus, and on each of the menus you attach something called a queue action, and I will get back to that the next slide. So because menus and toolbars are kind of interchangeable, so often you have menu items that also appear on toolbars, and many of these toolkits have combined instead of having menu item, toolbar item, you have an action object instead. And the action object can be shared between the menus and the toolbars. So an action is a generic connection in the user way. It handles the icon that is going to display in the toolbar, the text that is displayed in the menu, and the shortcut that is used to be able to press a key and initiate that action at the same time. And you connect events or your the code is connected to these actions directly instead of the controls. So you don't connect the menu item object to your source code. You connect action object to your source code. So the signals are going from the action object to your code. So how can that look? So we're going into the code here, menu 1. So I start with creating an action here. So I have here self my action. I attach that to my window here, and I say here that I want the shortcut, the keyboard shortcut that is used to trigger this action is Control T, and then I also connect my source code here to what's going to happen using the triggered signal. So an action doesn't send clicked because it's can be a toolbar and a menu, so it's called triggered, and it's the same principle as for clicked. And you connect that to my on my action here. So I have added a on my action method in my class, and it calls a message box here, which I will go back and cover a bit later. And the message box is basically a dialog box saying something happened, press OK. And then to be able to display the action, I need to create a menu. So in this case here, I have actually inherited from a different main class. In this case, it's a main window. And main window, the difference from a Q widget is that it can handle a menu bar. So it has a special function called menu bar that returns the current menu bar. And we add a menu here called file. And to the file menu, we added our action here, my action. So this will create a file menu with a single drop-down menu. So let's see what happens when we run this. You get this window here. It's a bit small here, but you can see we have a file menu here, and you can see I have an action here. And if I press that, you can see I get this message box here. But I can also click Control T. I will do that now on my keyboard, and you see it displays that as well. And having keyboard shortening is something that the users like because even if it's very user-friendly to have a menu or a toolbar, sometimes when you get up to speed with your program, you would like to do things quickly. And then having shortcuts provide the user with a way of quickly triggering action without moving the mouse. So that is why it's important to kind of provide the shortcuts as well. if possible. I mean, you have a limited amount of keyboard shortcuts, and some of them are already taken by Windows and other programs. So you have to be careful to what shortcut to select. So that was menus, and then toolbars are added almost in the same way. There is an add toolbar to the main window class, and then you add actions to the toolbar. It's that simple. So let's go to toolbars here, toolbar 1. You can see I have my single action here. I only use triggered on the action. I don't have to do anything more to kind of get my code to execute. I have my menu definition here, and I have my toolbar here. So, and you can see I add the same actions to the toolbar as I did to the menu. And I have a single method to respond to that. So running this will create an application that looks something like this. You can see here I have a toolbar here, and I can actually move this toolbar around. That functionality is kind of built in. You don't have to code for this. This is part of the toolbar. And if I click this one, you can see I get the same action here. And to show a bit larger example here, I also have a larger toolbar here for a larger application. So this is how it can look when you have a bit more complicated application. You create all your actions first. So this is new, open, save, exit, cut, copy. So first you define all your actions, then you define your menu, and you connect your actions to the menu. You create your toolbars. In this case, I have 2 toolbars, and I connect all my actions to those. And here you can see you can also add images to your toolbars in this case. So you can move them around, create custom look and feel of your application. And the images are set by set icon here. And you can't just give a file name. You need to kind of create a Q icon object which you pass along to set icon. And that is the way you kind of set the graphics in your user interface. Up until now, we have been looking at you place the control at a certain coordinate in your window. The problem is that with that is what happens when you resize the window. The controls will stay, and you need to manually move your controls to be able to adapt to window changes. And what you can do to solve that in Qt is using something called sizers. And sizers are special objects that can automatically resize or lay out other controls. And the best thing is to just show you how that works. So you have for example, you have 4 buttons here, and you have and you want to lay them out vertically. And then you can use something called a VBox layout. And that is a sizer that will you add a lot of controls to them, and it will automatically arrange them vertically for you. And then you set the layout of the Q widget here to this VBox here. So instead of adding the controls directly to the main window, you add them to a layout, which is still added to the window. We go to VBox sizer here. You can see I've added controls to the vertical box layout, set the layout of the window, and you get something like this. And if I resize the window, you can see here it automatically resizes the controls in the window. It also checks to see the minimum size that you can have on the control. So if the control says that it can't be smaller than a certain point, you can't resize it. It kind of gets stuck here. And if you resize it another way, it tries to distribute the controls evenly in the layout. So you didn't have to specify any control or anything. You just add them to the control, the layout, and it will fix the positioning of the controls automatically for you. And you can do the other way around. You can use the HBox layout, which will lay out on the other direction. So if we go to HBox sizer here, only difference is that we have a different class here that we create, and we add the controls to this class, this object. And you get the buttons in this direction as well. So now it will spread evenly in the horizontal direction instead of vertical. Now you can see it was centered in the middle here as well, a bit like that. And of course, you can combine them in different ways. And usually, when I do things like this, I try to do this on paper first to kind of find a proper design of my application. So I need a row of buttons on the lower left. I have an editor on top, and then I kind of draw the structure of controls the way I want them to be. And here you can see I have 4 buttons here that go on top, and then I have 4 buttons that goes horizontal on the bottom here. And the outer layout controller is the vertical box. So the one that we connect to the window is the vertical one. And then we add a horizontal box as the last row of the vertical box. And also you can add springs to your layout as well. So if you don't want the buttons to be able to spread out evenly in the controls, you can add a spring. And you do that using the add stretch method. And that will kind of add an invisible control that will kind of push the other controls up and the other ones down. So if we look at this one here, you can see I have 8 buttons here. First, I create a vertical box, add my 1, 2, 3, and 4 buttons in that one. I create a horizontal box, which I add 5, 6, 7, and 8. And then I add a stretch to my vertical box, and I add a layout to my vertical box that is the horizontal box. So this is to create the layout hierarchically. And that will give me a user interface that looks something like this. And if I resize it in this way now, you can see here that these buttons will stay on top because there is an invisible string here going in this direction here, pushing the buttons up. Same thing here, you can see that they will distribute here as well, but I could have added the stretch in a different place as well. So let's see if I can do. I add a stretch after the second button here. You can now see that I have a spring here. So the first 2 buttons here are pushed up and the other ones are pushed down because there is an add stretch here, which is a kind of a spring that pushes the controls out from each other. This is the way how you can design your user interfaces and have a dynamic that they scale automatically when you resize the window. But there is another layout called grid layout, which is just what it sounds like. It's that you place the controls in a grid-like fashion. And I probably need to better to show it live here. Grid layout. So I have 9 buttons here, like a calculator. I give the special policy for each button here that they should expand in both directions. By default, it only expands in the X direction. So I added so they expand in both directions. And then I add the widgets here. And instead of just adding the widget, I have 2 extra parameters here, which are the rows and columns of the grid. And you don't have to tell the grid to be a certain size. You just add them and give the position of them. You can also add condensed margins here to control the spacing between the controls. Outside the controls, and then you can specifically the vertical and horizontal spacing between the items. You can also tell certain columns to stretch So in this case here, I tell column 0 to have a relation, and it should only stretch 1, and then 4 is how. If you can say the first button should be size 1, the second will be size 4, and the third will be size 1 again. Same thing with the row stretch here. I will run it and change some of the parameters you can see here. So now you can see I have 9 buttons here, and if I resize it here, you can see here that this button here is kind of a relational size of 1. This is 4 times this one, and that's 1 again. So that controls the sizing of them. The spacing between them is controlled by this. So if I set 10 here, run it, you can see here that now I have only 10 pixels between each control here. And the content margins here, if I put them to now you can see that the buttons are close to the window border here. So this controls the margins, same thing you have in a Word document, for example. So grid is, if you have a user interface that is grid-like, you can use that. And of course, you can have a grid interface combined with the vertical and horizontal box sizes as well. So you can have a left part of the layout where you put buttons in, and you put that in a certain grid location as well. Now we're going to go through some of the controls and the dialogues that you can have as part of the Qt distribution. And standard dialogues are dialog boxes that you use that are very common in when you design user interfaces. It could be you want to show a message to the user. You want the user to be able to select a file. You want the user to select a color. And you don't want to create your own user interface for that, because that's already built into Windows and Mac and also Linux. And Qt can bring those up for you with a single function. So let's start with the dialogues here. So this is I just created an application that can open a dialog box. The interesting thing here is this line here. So there's a message box class that has an information method that you can call directly, and that will create a window attached to my main window, and it will display a caption made element, and then ouch will be the message that it will send out. So if I run this, and if I call my method here open, you can see this is the message box that will be created automatically for you. You don't have to manage it at all. And you can also see here that I can't use my window here, because until I press OK here, this window will be locked. So that is a standard behavior of message boxes, that they kind of block the user interface until you press OK, and then you can continue here again. Another dialog box that you can use is, perhaps you should overuse it, but instead of information, you can put critical. So when you have information, you got this kind of informational icon. If you do critical, you will get this instead. Also a different sound. You get this kind of red serious button here, and text is this one instead. So the only difference is that you get a different icon. And my recommendation is use these very seldom in your applications, only if there is a really critical problem. If your calculation is done, just bring up an informational dialog box, for example. Calculation is done. Critical is kind of for situations when you really have to get the user's attention. So use them sparingly. There is also one called warning here, and that is similar, but you get a warning triangle instead. So this could be kind of also a bit between attention, information, and critical. There's also one that you can actually ask the user for certain things. For example, do you really want to remove this or restart your calculation or something? Then you can use the question method of the message box. And here you can give, of course, the title, and then you can give the title, and then you can give a question here, and then you can provide which buttons to provide. So in this case, yes, no, and then finally you can specify which of these should be the default. If the user just presses OK or enter, it will select no. And then when that message box has been displayed, you can actually query here. So the result here, if result equals a message box yes, then you do something like this. Otherwise, you do something like this. So let's see what happens if we run this. You get remove, yes or no. You can see here that the no button is kind of pre-filled. So if I press enter now, no will be the default. And if I press yes here, you can see I pressed yes. So that's a very easy, if you want to ask a question and don't have to code much of your own code, there is a lot of built-in functionality in Qt to do this. Another thing that is often common in application is to ask the user for a file. And there is a special module called QFileDialog, which has methods called getOpenFileName, which will open a file dialog and actually use the system file dialog on each of the operating systems. So this will display the one that is suitable for your operating system. And it will return you a file name, and then you can display the file name. And if there is no file name selected, the string will be empty. So you can check if file name is empty, then you can not empty, you can display the file. Otherwise, the file is not selected. The user has not selected any file. You can also give filters that will display only the certain kind of files with a certain extension. And if you add a parenthesis with star INP, for example, it will only open INP files. So let's see how that looks like. So you can see here I have a file dialog here, get open file name. Now I have a filter here for any files. And then I check for if I selected the file name or not. So if I run this here, you can do file open. And now you can see I get the standard Windows file selection dialog. And that is actually built into Windows operating system. So Qt will call the correct default file dialog on the operating system. So if you have a Mac, you will get the Mac file dialog selection. So here I can select any file here, and when I press open, you will get a complete full search path of that file. And if I do cancel, nothing will happen. It will return a string. It returns a second parameter which we don't use, and that's why we have this extra comma underscore. So this get open file will select the already existing file on your file system. But in many cases, you want to ask the user for a new file name. And that is done using the get save file name, really almost logical. And here is saying you can specify a filter, and then that will force the user to, it will check that the file selected will have that extension. So if the user only selects a file without the extension, that will be added to the file name as well. So let's run here. You can see here I get a file dialogs chooser here with an empty file name box here. And you can see here the filter is INP files. So if I go test here and I press save, you can see here that the function will automatically add INP to the file name. If I don't do that, if I do actually test.inp, you will still get INP. So we'll check, make sure that you have the correct extension as well. So that was the file dialogues. And next I will go through some of the common file dialog types in Qt. And the main idea with this control is to get input from the users to the application. So if you want to hide the width of your problem size, you have a control for that. If you want to have options, you can do that as well. So we'll start with a checkbox and radio button. So checkbox is a single control that can have a state on and off. And it's compared to kind of switches, you can switch on and switch off the behavior. The radio button is a special case of the checkbox. So a radio button has to be grouped in some way. So if you put radio boxes on a single window, only one of these boxes can be checked at the same time. If you want to have multiple groups of options with many, you have to group them in groups. Then only one of the states of the radio button can be checked in each of these groups. And you check the state using set the state using check state, and you can check state to query the state of the control. Radio button checked is checked. And I will go to checkbox. There's the control. I create a checkbox like this. It has the same property. You can set the position, and you can see here I pre-select this button. Otherwise, if you don't do it, it will be false or unchecked by default. It has a signal called state changed. So when you click that, it will connect, call this signal here and call my method here. It's not always that you need to have the signal connected for checkboxes, because you can query the checkbox afterwards to see the state of it. So there is not always necessary to be able to check when the user exactly clicks the checkbox. So you can see here I have a checkbox. It's pre-selected. If I click this one, you can see here it calls this method called onStateChange. Same thing here. So here you use this check state method to check the state of the control. Radio box. Here we have two radio boxes, radio buttons, and they behave principally the same way as a checkbox, but only one of them can be selected at the same time. So if you look here, it looks something like this. This is the pre-selected one. If I click this one, the other one will be unchecked. And you use the same here to check. So you can use the same methods to kind of check the state. A combo box is another control that can be used to ask the user for a selection of multiple options. And when you click it, it will drop down the options, and you can select from that. And the good thing with a combo box, it takes up a little space and can have a lot of information in it. So it's kind of an extension of a checkbox with multiple options, but hidden away. You can also, there's a signal called current item change, which is called when the user changes an option. There's a method called current index to query the currently selected item in the combo box. So let's see how we do that. Combo box there. Yeah, you create it like this, and then you add options to it using the add item method. So here I have 4 options in my combo box. I can pre-select the one option that is selected. So that is 0, 1, 2, 3. So this should be alternative 4 should be shown. And then you can connect the signal current index changed to a certain method. And that method needs to have an extra parameter called index that will be the one, it will come with the selected item index. So you can see here that alternative 4 was pre-select. And if you click this, you get a list of all the options you can select. And I can select this one here. And you can see here that you can get out the current text as well. So you don't have to, if you don't want to go through the index, you can always check which text has been selected using the current text. Otherwise, you can also have current index. That's two the same. Slider is a control, just like a mixing table or DJ table. You can control the volume in different ways. There are options for selecting the range. Also, you can have fixed positions in the control. They look something like this. You can have a vertical slider and you can have a horizontal slider. And you select that using the Qt vertical or Qt horizontal option when you create the control. And it looks something like this. Here I set the slider. It has a maximum value of 100, minimum value of 0, and I can pre-select the value using set value to 50. There are two signals, one signal you can connect, value changed. That will call the value, call this every time a slider is selected, will call this item here. And you can get the value from the slider using the value method of the object. So if you run this, you can see I have two sliders here. If I change this one, you can see it calls the value changed signal all the time, and the same thing for dragging it on top and bottom here. So this is for making more easy way for users quickly to select values without entering values from the keyboard. So, Listbox, very similar to combo box, but it actually displays several of the options directly in the list in the user in the control. It can also support multiple selections. So you can have a list where you can select multiple items individually. And also when the items exceed the size of the list box, it will actually add scroll bars to the control as well. So let's see here, list box. This. You can see here that I have create a list widget, and then I add items to the list box here. 100 of them, and you will see that when you set current row will set the currently selected item, and the same thing you can have current row changed, and you connect that to a method here. So if I run this, you can see I have a list box here. The 0, 1, 2 is selected, and you can see here because I have 100 items now, I have a scroll bar here it's automatically added here, which I can move up and down to show the items. If I select one here, you can see here that it displays you the index and also the text of that selected item. And you can, if you set the options correctly, you can also have multiple selections here. Now this, by default, it's only one selection at the same time. Line edit is probably the one control that you will use the most, because that's the one you will be able to ask the user for values that they can enter by using the keyboard. So it shows the text box where you can enter values, and then you can set the text contents of that line edit using set text and dot text here. So the controls in Qt here that we're going to use always kind of mostly handles values using text. You need to kind of convert back and forth in text. And I will go through an example here at the end of the lecture where I illustrate this. So let's see here if I can go line edit. So I have a line edit button control here. I set the text here to text, and I also have a button here. When I press the button, I will display the current text here. So I use the text method here to get the text of the control. So this is, you can edit the text here, and you can query the text here, and you display it like this. So this is kind of a small text editor that you can use to let the user enter values of your application, for example. Now that we have all our tools in our toolbox, we need to kind of think a little bit about how we connect things together. One easy way would just kind of to put your calculation code in your event methods, and it kind of create a single source code for everything. But it could be that at some point in your application's life, you want to change the user interface. So perhaps you don't want to use Qt, you want to use a web interface. And all of a sudden you have all your functionality embedded in your user interface code. And that's really hard to kind of separate. So one idea that is used often in user interface design is that you define a model class that defines your model without user interface. And then you have a view class that displays your user interface, and the view class uses the object to kind of communicate. So you have your object model object in a separate module in Python, and you have your view in a separate module. And then you can much easier separate your user interface code from your actual computational code. As I said, it's important not to mix user interface code with simulation models. So the user interface code should basically just kind of how to handle the user interface logic and kind of stay out of the simulation code. And you need to also handle the user interface and model updates in a consistent way. So what I usually do is I have in my view control, I have two methods, one called update controls that will take the parameters from my model and update the user interface controls for that. And then I have an update model that will go the other way around from the user interface view, convert the values to the model. And then you can have in your model, you can have code, for example, saving a reading from disk, and so on, creating a new model. So basically the model should be able to handle the functionality of your computational code without the user interface aspects. And then you implement all the user interface back in the view class. So let's create a really simple model here. And that's the kind of very not useful model here, but in this will contain only the properties of the model. So in here I have values here, I have options, I have alternatives. The model can print itself. You create the user interface here, and then you display the values in that user interface. So you have in your model, you have you kind of go from update controls will take the values from your model and set the text here, and also do the conversion here. So if you have a value, it will convert that to a string before assigning the value to the control here. And if you have checkboxes like this, you have to kind of actually do an if statement here. So if the model alternative is 1, then you set the checked for all 1 radio, for example, to true, and so on. So you need to build that logic in here. But then you also have the way of going from the controls to the model. And then you need to be a bit careful here. So if we have a value in your controls, you need to do a floating point conversion. And here you also need to, at some point, add error correction. So if the values are text and you convert it to float, you will get an exception in Python. So you need to be able to handle those exceptions as well to be able to create a robust user interface. So to illustrate this, I will create, because I'm from structural mechanics, of course, you have to do a simply supported beam. And I will create a model and a user interface for that simply supported beam. And the model is extremely simple. There are some relationships here, so you can calculate the shear forces and deflections at certain points of the beam, and also the bending moments of that beam. I want to encapsulate that into a computational model. And the idea how to use this, just the model, is that you create a beam object, which is from the class beam simply supported. And the beam has an A and B properties, just like the things here, A and B. We have a force P, which we can add as a property here, E for the elastic modulus, and I here for the moment of inertia. And then we can use the model like this. We can print it. There is a V method here for the deflections, and then you have the sectional forces and the moment of bending here. So this is the kind of main functionality of the model, and the model doesn't know anything about any user space. So we can implement it like this. We add a lot of attributes here hidden, and we implement them as properties at some point here. And one thing you need to kind of handle here, and this is an idea that you can think about using, is how you convert to floating point without crashing. So one thing, so usually I use a function called toFloat. It will have a new value, that is the thing coming from the text control, and an old value, that is the previous value of the model value. Then I have an except here. I try to convert this to a floating point. If I get the value, I return old value. So basically, if the user enters something wrong, we just go back to the previous value. If everything went well, we return B. So in this way, you can add this to your properties. So in this case here, I have a setter here. So if you give this a text input, it will try to convert to float. And we use the previous value as the default. So if something goes wrong here, you will get the previous value of A here. And an interesting thing here is also that you can actually, you don't have to care about the data type here coming in. You can give it a string. Anything that can convert to a floating point will work in this here. So this is a very good illustration of how properties can be used to guarantee your data is correct. So you can kind of make a check here when the user assigns a property, and you can only assign it to be a floating point, and it will handle the case where you give it wrong data automatically. And then I have some my methods here for calculating the deflections and calculating the section forces and the moments. And here I use, just to make the formulas easier to use, I give them shorter names here. And that's perfectly okay, because self underscore A will point to this reference automatically. So this will make it much easier to make the formulas more correct. So now I want to create a user interface that looks something like this. The user should be able to enter 1, 2, 1,000 and elastic modulus. And if we change a value, it should automatically update the table below. So what we then do is we create a beam window class. And I import my beam model as the beam model is stored in a separate module called beammodel.py. Import that as beam model. And the first thing I do in my window creation is that I create a beam object that I attach as an attribute to my class. So every time I create a new window, there is a beam object available for me. I create my user interface, and then I update the controls. So I set the values from the model to my controls. I update the text edit here to display the table. And the init view looks like something. I create little labels, and then I create also connect. When editing is finished on the text values, I call onEdit finished to update the model as well. So implicit looks something like this. Update controls will set the text here, convert the values of A, B, P, E, I of the model to text values in the controls. Going the other way around, update the text edit will do the plotting of the values in the text, so the values of the beam. And then I have update model going the other way around. And here you can see I assign the properties just like this. I do a text edit, I assign A with a text string. The toFloat will automatically convert to a floating point. So all the conversions from text to floating point will be handled in the beam model itself. And then I have to so I will do show how this looks like. Beam model. So I have this one here. You can see I have all the properties here. You can see if I run this here standalone, you can see I get a table here. I have a beam model object here. Beam UI. I create the GUI here. Add all the widgets to my things. I connect my handling for when the edit box has finished editing. Update controls here. I go from the model to the controls. And then I have update model here. I go from the controls to the model. So I kind of do the conversion here. So running this will display something like this. And you can see here, if I change a value here to, let's say, A, you can see here it will change back to 1 because it was wrong. But I can do 2 here. If I go to the next control, you can see it updates the display here. So I have go from 0 to 4. I can change the load, and you can see the value changes directly. So this is the way I think about how to implement user interfaces. That I separate them. I have one beam model and I have one beam user interface. They're completely separate, and I can, if I want to change it, I can do a web interface of this at some point later, and it will be perfectly fine. So now I've shown you the complicated way of doing user interfaces. There is another way. And if you imagine that user interface will be complex, that you have hundreds of controls, it's really cumbersome to handle that in your own user interface or in your own source code to create every control, give the relationship, set the different layouts in different ways. So there is an application that comes with a Qt called Designer or Qt Designer. It could also be that you have to use something called Qt Creator, because I think the Mac doesn't come with the Designer tool built into the Anaconda distribution, but you can install the Qt Creator application instead. But Qt Designer, the idea there is that you draw the user interface or in a tool that is it's like a drawing program. So instead of doing everything in source code, you do it graphically and design your user interface that way. What you do with this tool is that when you save from Designer, you will get a UI file, and that UI file is actually an XML file describing your user interface. And then in your source code, instead of specifying all your controls programmatically, you just load a UI file, and that will create all the controls for you. The only thing you have to do later on is connect the dots. So you connect the signals to your slots. So it basically is like you have all your controls all in the file, you just have to connect them later. And this is how it can look in your code. So you have your main class, your init GUI will be replaced by a single call here instead, UIC load UI. So you need to add a special statement here called UIC, which is a user interface compiler. So it will load and create controls for you. So you give the UI file and you give it where it should create the controls. In this case, we want our controls to be created in our main window class. And so you just give it self, and it will create all the controls at that location. So if you have a control called push button defined in the UI file, you can just do self push button set text, just like we did before. But it will remove the complexity of creating the user interface. So here we have a form and a form UI. If I run this here, you can see here, it creates a user interface like this. So the idea now, I will try to recreate this user interface in Qt Designer live here, and I hope I will make that before the end of the class. So what I do is I will bring in the user interface designer. It looks like this. So what I will do, I create a new file, and in this case here, I will you have multiple options to choose from here. The main ones are the main window and Q widget here. If you want to create a user interface with a menu items and stuff like that, you can use the main window start point. If you just want to use user interface without the menu, you can use widget here. So just to make it quick, easy, I will use widget here. Great. And now you will get a kind of empty window here. Oh, too big. And on the left side, you will see all the controls available in Qt. There's quite a lot. I haven't covered them all, but push button I have created, covered. On the right side, you have the properties of the controls or the selected thing. So what is selected now is the form, which is the main widget here. And you can see if I go down here, you can get a lot of, you can change the window title to my nice window. And if you change this on top here, you can change a lot of different things here as well. But the next step here, I will add my control. So to make it easy here, I will not think too much about the layout in the beginning. So first I just add some buttons here. And I want to have some buttons on the lower part of the window. So I will add some here as well. So you just click, drag, and release. And then I will do something at the right side here as well. And then I want to have a image here in the middle. And images in Qt is labels, and that's really illogical. But you create a label, and then you go down to, you can see here that you get properties here. So the base class object is on top. Then you have the QWidget, which is derived from object. And then you can see I have a frame, I have a label. So next, on the last part of the properties is the actual object here. So I can change, for example, this is my label. So I can set the text of my controls directly here in the property edit. So you can already in the UI file you can create the text that are in the controls. And you can also see here that on top here you get the object hierarchy that is created. The names here that is the actual names that you will use in your code. So my recommendation here is if you use UI, the designer, set reasonable names directly in the UI file. So do you know what actually you can find your buttons again. But the text button can also have a pixmap property here. So instead of displaying text here, you can display an image. So if we select here, choose file. I think I had a Python there. This one. Open. I loaded the image here. So now I want to, I can save this one here as form2.ui. And then I can go in my code here and I can change form2 here. And let's see what happens. We skip that for a moment because I don't have that set yet. You can see here that it loaded all my buttons just like they were appearing in the window in Designer. So you can see here it saves you a lot of work. Doing this in code, it will be 2 pages of code, but now it's just a single line here. Going back here again, now I want to kind of lay out this control, the window. So I want to have 3 columns here on top and a single column on the bottom here. So the first thing I will do is group the control. So I will select, for example, this bottom part here. And you see on top here, you have layout horizontally, you have layout vertically. There are something called using a splitter. We don't go through this, but then you have layout in the grid if you want that. But I want them to be layout horizontally. So I click this one here, and you can see they are grouped together like this. This button here, I want to have layout vertically. And this one's here should be layout vertically. And then I want to have this and this and this should be layout horizontally. So I will select all of these ones here. So we can get that, yes, like this. And I tell it to layout horizontally. And now you can see it requires me to have a bit bigger window. And then I want to have these two here should be layout vertically. So I will select everything again. And I actually I can set the layout directly on the window here by specifying like this. But now it kind of looks really bad. I want to have the buttons to be kind of more nicely laid out. I can use a vertical spacer here. That's the same thing as adding stretch that we did before. So I will go in here, put this one here. Same thing here. You have to kind of put them on the bottom. You can see where you put them by this blue line moving around like that. And also I want the right two buttons here to be on the right side here. So I will add a horizontal spacer like this. Save it again. And then we go back and see if it loads correctly. Oh yes, and it will be resizable now as well. You can also, if you select the main window. You can see here also how the organization of the objects here are organized. You have a form that is outer layer. You have a horizontal layout here containing a vertical layout and a vertical layout. Let's see here. I think you can specify. As you can see here, there is a layout stretch here in the bottom. So I selected the columns here, and you can select here that you want the middle one to be 10, and the other one's 1 and 1, and then you will get. We'll try to push the middle parts out, so it will be the largest part. So if I run this here again, you can see here that it tries to maintain that relationship between this, and this. So this will be 10 times this one here. You can also control that if you want the buttons to be not be able to be resized too much, you can go in here and set the maximum size here. So you can see this is the actual geometry here. So width is 75, and you can set the maximum size here to be width to be, let's see, 100. And then you do that on all these buttons here. This will prevent the buttons from expanding. So if you run this, save it and run it again, you can see here that, okay, it didn't want to do that. Okay, it should have gone, but in principle, it's a bit complicated to do live here. But the thing is that you can control how the different items change size here, and if they should be fixed or not. But the idea is that you can create user interface in Qt Designer, and you just load it here using single thing here. And the thing I wanted to show again was the naming of things. So if we go back here, recent forms, So for example, here, if I want to change the properties of this, you can go in here and I can set the name of this button, press me. But the important thing is also that I need to name the buttons in a certain way. So press me button like this. This will give it a name here, and that will also be the name I will use here to self press me button. This. So this is the name I gave it in Designer. This will also be the name in the code. And hopefully it will work if I press this one here. Okay. Okay, I have a, sorry, I didn't put a event method here, but you can see here I changed the text here to press me in the code, and it changed this button here as well. So it's important when you work here that you go through those things that needs to be accessed in code have good names as well. So let's see here. That was, I think, everything for today. So for the next, for the seminar this week, I will do 2 more bit larger examples, and then I will ask questions as well. You get asked questions on your assignments. So this was what I have today.